Good morning, student. Today we are going to see a new chapter of physics, which is motion in one dimension. Motion of the body in a one dimension. You know, two dimensions, which is x, y axis. Three dimension, you know, that is x axis, y axis, and z axis. And a one dimension means in a straight line. Related to motion of the body in a straight line, this chapter we are going to discuss. Before going into some theory in the motion in a one dimension, let me explain you about the physical quantities. There are a lot of physical quantities like length, mass, time, electric current, volt, then say power, pressure, energy, speed, work, displacement, distance, velocity, acceleration. Lot of quantities are there. But these quantities, physical quantities, get divided into two different categories as per their requirement, as per their nature. First is a scalar and second one is a vector. What do you mean by scalar? A physical quantity which requires only the magnitude. A physical quantity which requires only a magnitude to express itself is known as scalar quantity. While vector acts a difference, I can say it is a physical quantity which requires magnitude as well as the direction where the quantity is going or the body is going. So these are the two major categories of the physical quantity. One is a scalar and one is a vector. Scalar needs only a magnitude while vector needs magnitude as well as direction. Now let's see total discussion about the scalar. I told you the definition. Okay, the physical quantity which have only a magnitude, no need of direction is known as scalar quantity. Let's take an example. If a mass of the body is say 10 kg, then this statement, mass of the body 10 kg, have a complete sense. It have two parameters. You can see here at 10 kg. Two parameters it has. 10 represents a numerical value while kg represents a unit. So when you go to the when you go to ask for a jaggery to a grocery shopper, then you are saying give me a 1 kg jaggery. Rather you are saying give me a 5 kg of sugar. You are demanding for 2 kg of oil, 2 kg, 5 kg, 1 kg. That much is sufficient to make a complete sense of your sentence. Shopkeeper can understand what you want. Means only 5 kg, 2 kg and 10 kg. These two words explains the full meaning. There is no need to tell a direction. Is there any need to say that I want a sugar of 1 kg toward east, I want a 2 kg of the sugar toward north? No need to say direction. There is no need of direction. So which are the quantities, physical quantities goes under the category of the scalar? These are mass, length 5 meter, 10 meter. We are not saying about the length. I want a cloth of 5 meter toward east. No need. Then time is the second. So we can't say that 5 seconds toward east, 5 seconds toward west. No need. Distance is say Myanmar to India. How much distance it is? 90 kilometers. No need to say 90 kilometers toward east, 90 kilometers toward west. Density, volume, speed, work, energy, power, pressure, lot of quantities. These are some examples which you already studied in your lower classes. So I put those examples. More interesting thing about the scalar is that the arithmetic operations such as addition, subtraction, multiplication and division are done using simple arithmetic methods. How we are doing 2 plus 5 is equal to 7. Similarly, over here we can do 5 kg plus 2 kg is equal to 7 kg. Subtraction, same way. Multiplication, same way, as well as division by simple arithmetic methods we can do with these scalars. Now, let us know more about the vector quantity. Initially, only I state you the difference between the scalar and vector. What is the definition of vector? The physical quantity which require magnitude as well as direction. Then and only then we can say it gives us a complete sense. Otherwise, sentence has no complete sense. Now, if I take an example, particle get displaced from its place for 10 meter, then question arises, in which direction it goes? If I say bus just has departure from the bus station, then question arises, in which direction it goes? Right? Means, whenever we are saying or talking about these physical quantities, then we require a direction. Then and only then the sentence have complete meaning. Here, if I say body moves 5 meter toward east, then this 5 gives us a numerical value, while meter shows us a unit and east shows us direction. It means in case of scalar, we have find only 2 requirements are there, numerical value and unit. Here in the vectors, we can see 3 requirements. Requirements are there, numerical value, unit and direction. Let's see some examples of this vector quantity. Displacement, velocity, acceleration, momentum, force, torque, weight, moment of force, dipole moment. All these things require direction. Next point is that negative sign is given, means 5 minus 5 meter. Minus 5 meter toward east. It means minus sign indicates opposite direction. Minus sign indicates opposite direction. It follows different rules other than arithmetic methods. We have seen in case of the scalar, that scalar arithmetic operation can be done using the simple arithmetic methods. But here you can't do addition, subtraction, multiplication and division of this scalar using simple arithmetic methods. You can't. Different rules are there. It follows a different algebra to do these operations. Now, how to represent? These physical quantities are represented by arrow-headed data. If I say about the velocity, then velocity denoted by V and arrow over it. If I say about force, F, arrow over it. Acceleration, small a, arrow over it. Okay? So in all these quantities we can see that this is the representation of vectors. Either you can write like this or bold letters, small, bold, small letters. Okay, bold. So either arrowhead or you can say bold. This is how we can represent these quantities. Now let's talk about the new point. New point is that rest and motion. We know that in the universe, all the bodies are in motion. You can say me, sir, what are you talking? What are you talking about? A stone which is lying on the ground is also in motion? Yes, definitely. Everything is in motion. Everything. Not a sun also in a stable place. Sun is also moving. We know that. See, a moving car, okay, a moving person, right? Then running people here and there, right? Then I can say running vehicles, all vehicles keep in mind. All the planets are revolving around the sun. Stars and suns, even stars and sun, even we are saying that they are at a constant place, but they are also moving around a point in a galaxy. And these galaxies are also moving in other. Means I can say everything is moving. Stone lying on the ground is also moving because our earth itself moving around itself, which is known as rotation, as well as it moves along a sun, around the sun. It moves around the sun. So how can you say that the stone which is lying on the earth is in rest position? So in the universe, everything in the universe is in motion. But how can we explain that? The definition of the rest. Rest की definition हम किस तरीके से लिख सकते हैं? We can say that the body is in state of rest if it does not move with or it does not change its place. That is the proper definition. Change its place. A body is in state of rest if it does not change its place according to surrounding. According to surrounding. Okay? Next sound. Exactly next sound. Okay? Then it can be said next state of rest. So, when a stone lying on the ground, you find it now lying at the same place, and after some time also it is lying on the same place. If you don't find it, change it of place in that stone, place of stone, then what you can see? The body is in state of rest. Now, is it a unique definition then? according to the surrounding. Okay? Is it unique one? Yes. If you are sitting at a railway station, then what do you find? You find that train is moving in front of you. Then you can say the train is in motion. You are at the bench, there only at the railway station, and if you see, trees are in the rest state because trees does not change their place according to you. According to you, the trees does not change place, but according to you, train shifted from one place to another place. So you are saying that tree is in a rest position and train is in motion. But if you are sitting inside a train and train is moving, you can see that the trees are going back, running back. What you find? You find that trees are in motion, but actually train is in motion. How it is related term, that we will discuss later. But what is my point to discuss? It is a body is in state of rest if it does not change its place according to the surrounding next to it. उसके पास में होने वाले सराउंडिंग के हिसाब से अगर वो उसकी जगह नहीं बदल दिया, then we can say rest position. A person lying as a potato couch in front of the television, then what we can say? We can say, what a rest body. What is the person he is taking? Which type of person he is taking rest? Means he is lying there only for an hour, for 2 hours in front of you. That time you can say that the person is in a rest position. So according to the study, that is important. Now, how can we define a motion? Same way, we can say that a body is in state of motion if it changes its place according to surrounding next to it. Okay? So that is the simple definition. And I can say here moving up. So I hope that you understood about the rest as well as motion. Right? Next topic that is related to chapter we will see in the next period. Thank you.